Now let's take a look at deep learning. This is a subfield of machine learning and takes things a step further by utilizing complex artificial neural networks to process information and make even more sophisticated predictions. Here's how it builds upon the foundation of machine learning. Deep learning algorithms are inspired by the structure of the human brain. The human brain is comprised of billions or trillions of interconnected neurons that transmit information through electrical signals. Deep learning models mimic this structure by using artificial neurons, also called nodes, arranged into layers. These layers are interconnected, allowing information to flow and be processed throughout the network. Unlike traditional machine learning algorithms that might use a single layer to analyze data, deep learning utilizes multiple layers, often stacked on top of each other in a hierarchical fashion. This is where the term deep comes from. The more layers a network has, the deeper it is. Each layer performs a specific transformation of that data, extracting increasingly complex features as it progresses through the network. Deep learning excels at learning representations of data. Imagine showing a child a picture of a dog. At first, they might simply recognize it as a furry object. But as they see more pictures of dogs, they start to identify specific features like floppy ears, a wagging tail, and a wet nose. Deep learning works similarly. The initial layers focus on identifying basic edges and shapes in an image. As data progresses through the network, deeper layers learn to combine these basic features into more complex ones, eventually recognizing the entire object as a dog. Many of the training of what you would do in learning how deep um, neural networks work usually use this, like, can a neural network identify a dog or a cat or both or some type of animal from an image? And this is a classical way of learning about these deep learning networks. So training a deep learning network requires a significant amount of data, as you can imagine, and computational power. Um, and the process involves feeding the network labeled data sets, similar to supervised machine learning, as we learned in the last um, section. The network then adjusts the connection between its artificial neurons based on how well it performs on the training data. This process, called backpropagation, allows the network to learn and improve its ability to recognize patterns and make accurate predictions. Deep learning's ability to process complex data has led to a wide range of applications, include image recognition. Deep learning algorithms power facial recognition software, self-driving car image processing, medical image analysis for disease detection. Deep learning networks are also used for natural language processing. The deep learning is used in machine translation tools, chatbots, sentiment analysis of text data. Speech recognition also uses the deep learning models and are behind the voice recognition systems in our smartphones and smart speakers. Deep learning is a rapidly evolving field with immense potential. As researchers develop more sophisticated architectures and explore new training techniques, we can expect even more groundbreaking applications to emerge in the future. However, challenges like interpretability and bias in deep learning models need to be addressed to ensure responsible and ethical use of these powerful technologies. Next, we'll look at computer vision.